Next, we want to look at how would we derive higher angle identities from what we already know. And so we're going to derive a triple angle formula here for cosine. So really what I want to know is, what is the identity going to be for the cosine of 3 theta, or the cosine of 3x? What is the expression over here that we're going to end up with where cosine of 3 theta can always be broken down? Just like the sine of 2 theta is 2 sine of x cosine of x. What does it break down to? And the strategy we're going to use is taking what we learned in section 5.4 and break this down into 2 separate angles. The cosine of 3 theta we know can be represented as the cosine of 2 theta plus theta, where here the 2 theta would be our A value and theta would be our B value. So really what we're looking at here is going to be the cosine of A plus B, where ultimately we plug in a 2 theta wherever we have an A and a theta wherever we have a B. So cosine of A plus B we know is the cosine of A, cosine of B, minus the sine of A, sine B, and we know A is 2 theta and B is theta. Now at this point, we know some other identities from the first page. We know the cosine of 2 theta and we know the sine of 2 theta. So let's plug in those values that we've got. So cosine of 2 theta we know is 2 cosine of theta minus 1. That's actually squared. 2 cosine squared theta minus 1 times the cosine of theta. And here we've got a sine of 2 theta, which we know is 2 times the sine of theta, cosine of theta, times the sine of theta. And someone might ask, well, why did I choose 2 cosine squared minus 1 instead of the cosine squared minus sine squared formula that we had? And the reason for that is we want our final answer to be in all cosine. So it just saves step if I can put in just cosines right now. This one right here, the sine of 2 theta, there's only one formula for it, so I have to throw in that sine. So then here I can distribute my cosine in. So 2 cosine cubed theta minus a cosine of theta. Back here I'll distribute the sine in, or multiply the sine. I'm not going to distribute it to each piece since there's no plus, just we'll multiply the sines together. 2 sine squared theta, cosine theta. And now we know what sine squared theta is in terms of cosine squared theta from what we learned in the previous section. Actually, previous chapter. We know that sine squared theta is the same thing as 1 minus cosine squared theta. Now I've got everything in terms of cosines. So 2 cosine cubed of theta minus a cosine of theta. We'll distribute the 2 in and that cosine. So let me put that cosine in first. And then we'll distribute that 2 in. So minus 2 times cosine is minus 2 cosine theta. And minus 2 times negative 3 cosine theta would be a positive 2 cosine cubed theta. So now if I combine like terms, I'll get 4 cosine cubed theta minus 3 cosine of theta. So here cosine of 3 theta is 4 cosine theta minus 3 cosine theta. And I can verify that pretty easily on my calculator to show that this is true. If I pull out my calculator and in y1, I plug in the cosine of 3x, and then in my y2, I'll put in 4 cosine of x cubed. Actually, I should probably, just for safety measures here, put the 3 outside. So 4, and then put my parentheses, cosine of x, and I want that whole quantity cubed, minus 3 cosine of x. And if I look at my tables, I'm going to see that my tables are identical all the way down, which indicates that my two sides are equal. The cosine of 3 theta does equal 4 cosine cubed theta minus 3 cosine theta. Number 4, deriving a quadruple angle identity formula for cosine. So we're going to do the same exact thought process here. We know that the cosine of 4 theta is going to be the same thing as the cosine of 2 theta plus 2 theta. Where here A and B are going to be 2 thetas. So the cosine of A, cosine of B, minus sine A, sine B. All these are going to be 2 thetas. So cosine of 2 theta, sine of 2 theta, minus sine of 2 theta, cosine of 2 theta. And I'll allow you to continue to simplify that one on your own. It's all algebra from this point. But at the end, we are going to come up where the cosine of 4 theta is going to equal 8 cosine to the 4th of theta minus 8 cosine squared of theta plus 1. So I challenge yourself to come up with those. But same exact process that we had up here, where you're going to substitute in your cosine squareds, your sine squareds, your 1 minus cosine squareds, or whatever identities you've had to get everything into cosines and then simplify. So that's how you would expand higher level identities. If I wanted to, for the cosine of 4 theta, here I did cosine of 2 theta plus 2 theta. I could have just as easily said the cosine of 3 theta plus theta and used my 3 theta that I got up here and regular theta and solved it that way as well. But I would challenge yourself to see if you can come up with that given that start I've given you.